So we're gonna talk about solution to Legendre's equations. Any equation of the form 1 minus x squared y double prime minus xy prime plus n times n plus 1 multiplied by y is equal to 0 is called a Legendre's equation, where the parameter n for this section is taken only as a positive integer. Observe that x equals 0 is an ordinary point. Thus, a power series solution exists that is similar to solving a second-order differential equation with x equals 0 as an ordinary point. So take note that the general solution of Legendre's equation is valid only in the interval from -1 to +1. Legendre's polynomials denoted by p sub n, which is a function of x, are the solutions to Legendre's equations with n as a degree of the polynomial. So the following formulas are used to generate Legendre's polynomials. So we have the Legendre's recurrence formula, n plus 1 times p sub n plus 1 minus the quantity 2n plus 1 times n times p sub n plus n times p sub n minus 1 equals 0. So this formula is valid only for k equals 0, 1, 2, 3, and so on. Or n is equal to 0, 1, 2, 3, and so on. The Rodrigue's formula, this is the second method to generate the polynomial solutions of Legendre's. So p sub n is equal to 1 over 2 to the n factorial, and derivative with respect to x of the expression x squared minus 1 raised to n. So n will take the value of 0, 1, 2, 3, and so on. Okay, so these are the first six Legendre's polynomials, so the solution. So we have the p sub o, your this diagonal line. Okay, this diagonal line. And then we have p sub 1. Okay, we have p sub 3. The blue one. Okay, and then p sub 4, the violet one. And then the graph for p sub 5, this is 5th degree. Okay, is the red one. Okay. Okay, these are some of the properties of Legendre polynomials. No? So we take apply negative x to any p sub n, then that is also equal to -1 raised to n times p sub n evaluated at the negative of or the value of x, which is the negative of the negative of x. And p sub n at x equals 1 will always be 1. And then when x is equal to 0, your p sub n will always be 0 when n is odd. And your p sub n -1, it will always be -1 raised to positive n. And then it will always be equal to 0, the nth derivative, when n is even. Okay, so that's an example. So we use the Rodrigue's formula to generate the polynomials p sub o, p sub 1, and p sub 2. So we know that your p sub n is derived using the Rodrigue's formula or this formula. So when n is equal to 0, so we get p sub o here, and then 2 to the 0 is 1, 0 factorial is 1. And then d to the 0, so we have a constant here. Rather, this is equal to 1. So we now have x squared minus 1 raised to the 0, which is equal to 1. So therefore, your p sub o is equal to 1. And then for p sub 1, so we get, okay, so we have 1 over 2 raised to 1. 1 factorial is 1, so we have 1 half here. And then this is first derivative, no? So the first derivative, this is 1, so x squared minus 1, whose derivative is equal to 2x. So simplifying, you get p sub 1 equals x. And when n is equal to 2, okay, so the quantity here is x squared minus 1 raised to 2, and then we evaluate the second derivative. So we'll take, suppose this is your y, okay, so we get the first derivative, okay, by power rule. This is 2 x squared minus 1, 2 minus 1 is 1, then derivative of x squared will be 2x. And then for the second derivative, okay, this is 4 x cubed. So the derivative of 4x cubed is 12x squared. And then minus 4x, the derivative is minus 4. So using the Rodrigue's formula, when n is 2, you have 4 here. 2 factorial is 2. Okay. So 8, we have 1 over 8 here. And then the second derivative is 12x squared. Okay, minus 4. So we substitute. And then simplify, we get 3 halves x squared minus 1 half. Okay. Let's use this recurrence formula to solve the Legends equation. So we take k equals 0, k equals 1, and k equals 2. So this is the recurrence formula. Let's start with, this should be n. Okay, so when n is equal to 0, so you have 0 plus 1, 0. So you have p1 here, and then this is 0. So minus, but this is 0, no? Rather, this is x, sorry. This has to be x. So x times p sub o plus this n is equal to 0, so everything will be 0 here. And that gives you p1 minus x p sub o. And then equate to 0. So your p1, or rather, your p1 is equal to x p sub o, but p sub o is equal to 1. Okay, so your p sub 1 is equal to x. And for n is equal to 1, okay, you have 2 here. P sub 2 minus 2 times 1, so you have 3 here. X. Okay, this is x. P sub 1 plus 1 times 1 minus 1, so this is p sub o. Okay, so simplify, you get 2p sub 2 minus 3x, okay, p sub 1 plus p sub o. We solve for p sub 2. Okay, we solve for p sub 2. So we transpose, you get 3x squared here. P sub o is 1. And then minus p sub o. Okay? P sub o, by the way, this is your p sub 1, but p sub 1 is x p sub o from this expression. Or you can just substitute x p sub o by x here. No? So this is just equal to x. Anyway, so simplifying, solving for p sub 2 will give you 3 halves x squared minus 1 half.